Good morning, everyone. Sorry that I'm not here today. They had to, the herniation in my disc was a little more significant than they had anticipated, so I'm a little bit more in pain than I anticipated. But I will be back tomorrow, though. Just needed another day. So we do have another video today. Sorry. This one's going to be kind of longer. But good news is this is the last new material of the semester. So give yourself a round of applause. Congratulations. We're almost done. All right. Also, I want to thank you guys, those of you that turned in the first derivative example. I was actually quite impressed on how well we did. And if we made mistakes, they were just really minor mistakes. So thank you for taking the time for those of you that did it, which we all should have, but thank you for those of you that did. And thank you also, some of you I know went back and actually redid the work and resubmitted it, and I did see that and I graded those too. So if you still want to do that, please go ahead and do that today. I will take a look at them throughout the day while I'm at home. All right, so we are going to learn concavity and the second derivative test. So just a couple things here. The difference between concave up and concave down. So concave up is like a cup, and concave down is like a frown. Okay. One way that I always remembered it was a spoon. That when you like pick the spoon up to your mouth, that's gonna be concave up. You're going up, and that's where the indentation is for you to eat your food. Okay. This would be decreasing, increasing, decreasing, increasing. So we can have decreasing and increasing for both concave up and concave down. All right, so let's just practice finding the second derivative. Basically, all it is applying the power rule twice, okay? And this is why we need to make sure that we pay attention to notation because we will now be working with the first derivative and the second derivative. So we're going to go ahead and apply the power rule first. So we get negative 4x plus 4 plus 1x, which is just x to the negative second. Remember that you drop the number down in front and then you subtract 1. Okay, the derivative of a constant for the 5 is just 0, so we don't include anymore. And then for the second derivative, we do f double prime now, and we get negative 4, and then the constant here cancels out, minus 2x to the negative third. Okay, so all we did was just apply the power rule twice and just make sure that with constants, remember that constants are numbers without a variable, that the derivative of a constant is just 0. Okay, so let's go on to the next example. We'll just do this one together again. So we're going to do f prime of x, which is the first derivative. We bring the 3 down in front, so 3 times 5 over 3 is just 5x to the second. And then we have negative 1/2 times 2, so that's just minus x to the first plus 3. Okay. Then to find the second derivative, we apply the power rule again. So 10x minus 1. So again, remember that the derivative of a constant is just 0. So when we go to the second derivative, it's no longer there. And then if you just have x to the first, remember that it's just the coefficient in front. So since this is minus x, then you get minus 1. Okay, so what does concavity tell us? So if f double prime is negative, then that means we are concave down. If double prime is positive, that means concave up. Okay, so here's a little way you can remember concavity. So when Mr. Smiley is smiling, then it's going to be concave up, which is positive, and then Mr. Frowny is negative, so concave down. Just a fun little way to remember it. Okay, so basically what we have now is the first derivative and the second derivative test. Okay. If it's positive, For the first derivative test, that means it's increasing. And for the second derivative test, that means it's concave up. If f prime of x is negative, then it's going to be decreasing the function. And then that means that if f double prime is negative, then that means it's concave down. Now these don't have to match up, okay? So just because f prime is positive, that doesn't mean f double prime is positive, okay? I was just organizing it so you could see what the two tests tell us. So once again, these do not go hand in hand, okay? So if you want to put, I don't know, a big red mark here, these do not go hand in hand. They're just the different tests, what they tell us, okay? And then the point of inflection is where the function changes concavity. So notice that here we are concave down, and here we are concave up. All right, so let's go ahead and go to the next slide. Okay. And we're going to use the diagram to tell us fill out some information. So first of all, critical numbers, okay? So critical numbers is where the derivative, the slope of the tangent line, which is the derivative, equals 0. So here, the slope of the tangent line would be 0, and here. Okay. Remember that if it just says critical number, then you can just list the numbers. So x equals 0 and 3. If it said critical points, then we would have said 0, 0, and then 3, negative 27. Okay, so once again, numbers or values, you can just list the x numbers. If it asks you for the point, you need to actually include the ordered pair. All right, so where is the function increasing? So that means as x gets larger, the y values get larger. Okay, and there's actually only one spot where we are increasing, and it's this interval right here. So that would be from 3 to infinity. Okay, so now we're going to go ahead and do for when the function is decreasing. Now we have to be careful here because we're decreasing this whole interval here. But remember that when the slope of the tangent line is 0, you're neither increasing nor decreasing. So we have a break when the derivative equals 0, the first derivative. So we would write this interval as negative infinity to 0, and then 0 to 3. Okay? So once again, the reason why that happened is because anywhere where you have a critical number, that means that the slope of the tangent line is 0. So the first derivative is 0. Where that occurs, you can neither be increasing nor decreasing. So since we had a critical number here, we had a break there, even though we were continuing to decrease after the point. Okay. All right. Relative maximum points, remember that those occur when we switch from increasing to decreasing, okay? And we never have that. So there is no relative maximum point, which means there's no relative max value. Relative minimum points happen when we decrease to increase, which we do have one right there. Okay, it's the valley. So 3, negative 27 is the point. And remember that values are the y values. So this is negative 27. Okay, that's a big one. Remember that when it's asking you for a value, it's asking for the y. Okay, then the last thing we need to do is the point of inflection. That's where it changes concavity. So here we are concave up, and then we switch to concave down, then concave up to concave up. Okay, so we changed concavity twice. This was concave up, then we went concave down, and then we went back to concave up. Okay, so we are going to have 2 points of inflection. Remember, that's where the concavity changes. The first one is going to be at 0, 0, and then the other one is going to be at 2, negative 16. Okay. Okay, from there, we're going to go ahead and write our intervals. So the interval is going to be, concave up is going to be from negative infinity to 0, and then 2 to positive infinity. And then concave down is 0 to 2. So once again, make sure, like we do for increasing and decreasing, that your concavity covers the entire number line from negative infinity to infinity. So negative infinity to 0, 0 to 2, to infinity. So we cover that. Also be careful, because I did this a few times while making the video, that you make sure that you use your point of inflections and not your critical values. Now sometimes they will overlap like they did at 0, but the concave up started again at 2, not 3. Okay, so just make sure you're paying attention to where you're marking your points of inflection. Okay, next up, we are going to do the first derivative test and the second derivative test. Okay, let's try that again. Sorry about the, for some reason, sometimes the video freezes what you write when you move the screen. So we're good now. All right, so first thing we have to do is apply the first derivative test. So f prime of x is going to be negative 4x minus 4. Okay. Make sure that you guys are finding the derivatives correctly, because obviously if the derivatives are not correct, then the entire problem won't be correct. To find the critical points or the critical numbers, you need to set it equal to 0, because remember that they occur where the derivative equals 0, so that means the slope of the tangent line equals 0. So we get 4 to equal negative 4x, so x equals negative 1. So we just have one critical number at x equals negative 1. So that means we're only going to have one vertical line. We're going to mark that x equals negative 1. This is going to be f prime of x. This is f of x. And then this is the interval. Okay. Remember that you guys can go ahead and mark the intervals right away. So negative infinity to negative 1. And then negative 1 to infinity. So now we need to do some tests. Remember that since we are using the first derivative test, we substitute it in for the first derivative. So I'm going to test a number over here. I'm going to test negative 2. So f prime of negative 2 gives me a positive number. So that means that I'm going to be increasing from negative infinity to negative 1. Now let's test a number to the right. So I'm going to do f prime of 0. So negative 4 times 0 minus 4 gives me a negative number. So that means I'm decreasing on the interval of negative 1 to infinity. Okay. All right, let's trace our graph to see what happens. Okay, that creates a mountain. So this is going to be a relative max. We do not have any relative mins. So I'm going to go ahead and mark that right away. Relative minimum value is none, because we don't have any. Okay. To find the relative maximum value, now notice on here it doesn't ask for the point, it just asks for the value. Remember that you always have to go back to the original to find the y values. So we're going to do f of negative 1 okay, so we get negative 2 plus 4 plus 3, which gives me 5. So the ordered pair, the relative maximum value occurred at negative 1, 5. So the relative maximum value is just 5. Okay, so now that we've done the first derivative test, we're going to continue on to the second derivative test. So we're going to go ahead and take the derivative again from up here. So we get f double prime of x to just equal negative 4. So notice that there's no variable, there's only a constant. Okay, this is a really, really good active note for you guys. When there's only a constant, then that means that the graph is either all concave up or all concave down. Okay, I'll say that again. If you go to do the second derivative test and you just get a constant, remember that means a number without a variable, then either your entire original function is all concave up or all concave down. Okay? Which means then, if that occurs, that there is no points of inflection. Okay? And then in this case, if you get a constant and it's negative, then that means everywhere the graph is concave down. Okay? And it's concave up nowhere. And if you go back to the original problem, notice that it was negative 2x squared. Well, if you remember, negative 2x squared is going to be a quadratic. A quadratic is a parabola, and if it's negative, that means the parabola opens down. So we have to be concave down everywhere. So if this number is positive and it's just a constant, then that means concave up everywhere. If this number is negative, that means concave down everywhere. Okay. Now, of course, the next example, we're going to have a situation where we don't just get a constant and we actually have to apply the second derivative test. All right, so here is that problem. Let's go to the next page. And this is going to be our last problem of our notes and the last problem and notes of the school year. Okay, so first thing, we need to take the first derivative. So we get f prime of x equals 3x squared minus 6x, and then the constant is just 0. From there, we set the first derivative equal to 0. Okay, and this is an example where we factor. So we can take a GCF out, and we're left with x minus 2. And then anything that contains a factor needs to be set equal to 0. So x equals 0 and 2. Those are our critical numbers. Okay. Then the next thing we do is we set up our little chart, and since we have 2 x's, then that means we need to have 2 vertical lines. Okay, remember that we write those vertical lines in numerical order. So x equals 0, x equals 2. And then the top row is f prime of x, f of x, and then the interval. Okay. And we can go ahead and write in the intervals right away. So this is going to be negative infinity to 0, 0 to 2, and 2 to infinity. Okay, let's test a number to the left of 0. So I'm going to test f prime of negative 1. Remember that since we are using the first derivative test, we actually need to plug it into the first derivative. Okay, and we don't care what the actual number is. All we care if it's going to be positive or negative, and this is going to be a positive number. So that means we are increasing on the interval of negative infinity to 0. Okay, now let's test a number between 0 and 2. So I'm going to test f prime of 1. So that gives me a negative number. So that means I am decreasing on the interval of 0 to 2. And then I need to test one more to the right of 2. So I'm going to test 3. So f prime of 3. And once again, all I care about is if it's positive or negative. And in this case, it's going to be a positive number. So I am increasing. Okay, so the first derivative test tells us where the original function is increasing and decreasing, as well as where we're gonna have relative max and mins. Okay, so let's trace this to see where we have values. So where there's a mountain, we're gonna have a max. And where there's a valley, we're going to have a min. Okay, mathematically, it's when there's a max when it changes from increasing to decreasing, and you have a minimum where it's decreasing to increasing. Okay, so now we actually have to plug in those critical points to find the max and min values. Remember that anytime you're looking for a value, which is the y value, you have to plug it into the original. So this is going to be f of 0, where the max is. So we get 0 to the third minus 3 times 0 squared plus 4, which just gives me 4. So the max occurs at 0, 4. And then we have to plug in for the minimum into the original function, so f of 2. So I get 2 to the third minus 3 times 2 squared plus 4, which gives me 0. So the minimum occurs at 2, 0. Okay. I know I've been stressing this in the videos a lot, but let's just make sure that you guys are being really careful with notation. So knowing when we use f prime or f double prime or the original function itself. Okay, so let's fill in some information that we know. So we are increasing from negative infinity to 0, and then 2 to infinity. And then we are just decreasing from 0 to 2. Like I've said a bunch of times, make sure that this covers the entire number line and you just use the x value. So we cover the entire number line from negative infinity to infinity, so we're good. Relative max value are the y values. Okay, it doesn't ask for the ordered pair, it just asks for the y value, so this is going to be 4. And then the relative minimum value is going to be 0. Okay, now we need to go ahead and do the second derivative. So our original derivative, I'm going to rewrite it down here. So f prime of x was 3x squared minus 6x. Okay. So to find the second derivative, remember that you just apply the power rule again. So f double prime of x equals 6x minus 6. Okay. The point of inflection occurs when the second derivative is 0. So we're going to set this equal to 0. And we get x equal 1. So we do have a point of inflection this time. So remember that if the second derivative equals a constant, then it's either all concave up or all concave down. This equaled an equation of 6x minus 6, so we actually had to solve for the variable. So just like we did with the first derivative, we're going to make a chart, okay? And just like you did, if there was 1x, then you would do 1 vertical line. If there was 2 x's, you would do 2 vertical lines. Don't worry, we don't do more than 3. Actually, I don't even think we do more than 2 for the second derivative. So we have x equals 1. Now, this first row is going to be f double prime, since this is the second derivative test, f of x, and then the interval. So just like the first derivative test, we can go ahead and write in the interval of negative infinity to 1, and then 1 to infinity. Okay. You're going to notice that the first derivative test and the second derivative test, the process of them are exactly the same. It's just that it tells us different information. So we need to test a number to the left. Okay. So I'm going to go ahead and test 0. So f double prime of 0 gives me 6 times 0 minus 6, which is a negative number. So that means that f of x is concave down. And then I'm going to test a number to the right, so let's test 2. Remember that since we are doing the second derivative test, we need to test it in the second derivative. And that gives me a positive number, so it's concave up. Okay, so notice that the concavity changes, which means that there needs to be a point of inflection, which we had already found. So concave up is going to be from 1 to infinity. Oops, sorry, I wrote that in the wrong spot. So 1 to infinity, and then concave down is going to be negative infinity to 1. And then we still need to find the point of inflection. The point of inflection we know the x value, but since it says points, we need an ordered pair. So we have to take f of 1. Remember that anytime you're finding the y value, you have to go back to the original. So this is going to be 1 to the third minus 3 times 1 squared plus 4, which gives me 2. So my point of inflection is at 1, 2. Okay, so that's it. So once again, it's the same exact thing as the first derivative test. It just tells you concavity instead of increasing and decreasing. Okay, tonight for your homework, there's 4 problems, but you're actually only going to do 2 of them tonight, and we're going to do the other 2 tomorrow. So tonight you're just going to do numbers 1 and 4. And then tomorrow we'll do 2 and 3. And then I haven't decided. We're either going to do the check-in on Tuesday or Wednesday. Probably more likely on Wednesday. We'll do it online again, so that way I can provide you guys feedback through the day and you can actually see it. Remember that the test is Friday. If you're not going to be here Friday, you're taking the test Thursday, since today is the last new material. Okay? If you guys have any questions, please email me. I really appreciate you guys being understanding. Obviously, I want to be back there today, but my body's just not having it yet. So I will see you guys on Tuesday, though, no matter what. Once again, thank you. Thank you for being understanding, and have a wonderful day.